Okay, so do you guys have any doubts related to the last session which we had yesterday? I was telling you about pin diagram of AVR at Mega 16 controller, and I told you like in AVR at Mega 16, 80 stands for Atmel Corporation, Mega stands for Mega Family, and 16 stands for 16 KB of memory. So today we are going to start with the programming part as well. If you have any questions or doubts, you can ask me. Otherwise, I will continue to the next topic. Fine. So I told you yesterday that Atmega 16 has total 40 pins. This belongs to Mega family and it has total 40 pin IC structure. In those 40 pins, we have 4 ports, port A, port B, port C, and port D. So we can identify the IC using the half moon shape or this dot. The left side, as we have total 40 pins, so we're dividing into two parts, 20, 20. So left side pin 1 to 20 and right side pin 21 to 40. And accordingly, if we see on the left side, pin number 1 to 8 is port B, 0 to port B7. I told you yesterday that we have total 32 bi-directional pins. Total 32 bi-directional pins. That means we can use these pins as input and output both. Now, if we talk about the operating voltage, then the operating voltage of this Atmega 16 controller is 5 volt of DC, which has a range of 4.5 volt to 5.5 volt. So generally, it provides us the logic of 5 volt, and the logic 5 volt is always in the form of logic 1. That means if we give 1, it will give you the logic. If we give 1, it will give you 5 volt, and if we give 0, it will give us 0 volt. So let's write 0 volt here. Then in the same way, now we have port A, B, C, and D, and each port has 8 pins. That means 8 cross 4 equals to 32 bidirectional pins. So now if we have to suppose connect the LED, or suppose we have to connect the button, relay, alternator, lamp, motors. If we want to connect anything which we can operate at digital logic, we can connect using all these 32 pins. So that means at a time, if I want to connect all the motors here, I can connect maximum 32 motors here. So this will be the way of doing simulation and programming with Atmega 16. Now, if we see this pin diagram in simulation, let me pick here in Proteus. I'm picking Atmega 16 ATMEG Atmega 16. So here we have this controller. Atmega 16 also have different families, different series. Atmega 16, Atmega 16 2, Atmega 16 4P, Atmega 16 5. But I'm using the normal one, which is Atmega 16. And now let's drop it. So if we see this simulation diagram, the pin diagram in simulation software, the pins are not arranged in the same way which we saw in actual hardware. And why? Because here we have a half moon shape and a dot shape. But if we see here, there is no half moon shape, there is no dot. So if you see in this one, port B0, port to port B7, but here it's port A0 to port A7. But if you focus on the pin numbers are not going to change, although they are not arranged in the same manner, but they have the same functionalities as in the hardware. Now, for example, if we see pin number 1 to 8, it's port B0 to port B7. But here in this simulation, if we see port B0 to port B7, it's pin number 1 to pin number 8 same. There is no change, right? Now, let's try to understand about the programming part. The programming which we are going to use here is called embedded C programming. Embedded C programming. So whenever we start any programming, we have two type of functions. If we talk about C programming, embedded C programming, Java programming, Python programming, or any other programming, we have two type of functions. The one is predefined and the other one is user defined. So predefined functions are those which are already defined in the library of Proteus, in the library of your software. And user defined are those which user need to define. User mean we guys. So suppose if you are using any new variable or a function which is already not declared in the programming software, it will give us error. It will give us error. That might be a syntax error. That might be a variable error. That might be a functional error. So we basically need to define if any function is not predefined here. So for example, if else, else if, these are predefined here. These are called conditional loops. Whenever we have conditions more than one, we can use if, else, else if. If we have only one condition, we can use only if. If we have two conditions, we can use if else or if else if. So it's up to you how we want to use it. Then we have different type of operators. The first one is arithmetic operators. Plus, minus, multiply, divide. Second, we have relational operators. Relational operators are like less, greater, less greater, less equal, greater equal, equal, and double equal. So there is a difference in equal and double equal. And what is that? If we use single equal, for example, if I am saying a equals to 5 and a equals to 5. So what is the difference between both the lines? In the first line, we are saying assign the value of a to 5. So single equals to generally we use to assign the value, and double equals to we use to compare the value. So if we use double equals to anywhere, that means we are comparing. So generally, if we have to use double equals to, we will be using that with conditions in if or else if. Then third type of operator is called logical operator, and logical are like and, or, not. If suppose we have two conditions and we want both to be satisfied at the same time, we have to use and, because according to the truth table of and, 0, 0, 0, 0, 1, 0, 1, 0, 0, and 1, 1, 1. That means both the input should be high to keep the output high. In the same way, if we have two conditions and we want both to be satisfied at the same time, we must use and logic. And we can use the or logic wherever we need only one condition to be satisfied at a time. And we can also use not where we want the opposite of our condition. So these three type of operators we have. The first is arithmetic. The second one is relational. And the third one is logical. Now, after this, whenever we start programming, first we need to write two header files. The first one is hash include avr slash input output dot h. And the second header file is hash include util slash delay dot h. Like when we use C language, there also we have two different header files, hash include studio dot h, hash include conio dot h. In the same way, here we have two different header files. So if we use port A, port B, port C, or port D, that means we are using the input output pins of our microcontroller. So we must use this header file. So this header file is to include the input and outputs of microcontroller. Utility of delay. Wherever you use the delay function, you have to include this header file. Otherwise, your compiler won't understand what is the delay. Now, generally, if we say what is delay, the delay is time difference or the time duration between two conditions of output. The first one is on and the second one is off. The first one is on and the second one is off. So, time duration between on and off is called delay. And to provide delay, we have functions here. Again, a predefined function for delay, that is underscore delay underscore ms, and in braces we have to write the value of delay. So here ms mean milliseconds. Suppose if you want the delay of a second, you need to write underscore delay underscore ms 1000, because 1 second equals to 1000 milliseconds. In the same way, suppose if we need the delay of 2 seconds, we need to write 2000. Then another function for delay is underscore delay underscore us, again value. So us here mean microseconds, milliseconds and microseconds. Then we have registers. These are also known as predefined functions. We have total 2 registers here, DDRX and port X. DDR is called data directional register. DDR is called data directional register. Data directional mean we have port A, port B, port C and port D, which we can use for both the directions. As I said, it is bidirectional. So suppose if you are using port B as output, you need to tell your controller that you are using port B as output. And suppose if you are using port B as input, you need to tell your controller that you are using this port B as input. And how to do that? You can define that input output using this DDRX registers. And this work in 2 ways. Suppose if you want to define any pin as input, you have to write it as 0. And suppose if you want to define any port as output, any pin as output, you need to write 1. So we have only 2 logics, 2 binary logics, 0 and 1. So 0 indicates the pin as input and 1 indicates the pin as output. Now, the second is port X registers. So suppose if you define the port B as output and there you connected the motor and you want to turn on the motor. So to turn on the motor, you need to give the logic of 5 volt. So whenever you want to give the logic 5 volt, that means you have to write the logic 1, and whenever you want to give 0 volt supply, you have to write the logic 0. So port output registers we will use when we have to declare or when we have to write the high and the low functionality for motors, LEDs, coils, or any other thing. Now, what is X here? So X is your port. You might be using A or B or C or D. So whichever port you are using, you need to write that in place of X. Let's take an example. So suppose you have port B7. Port B7 we have to write on the MSB side, and port B0 we have to write on the LSB side. We have total 8 pins starting from 0 to 7. So I'm writing MSB to LSB, port B7, port B6, port B5. Why I'm telling you this MSB side and LSB side? Because whenever we write the program, PB7 always comes to left side and PB0 always comes to right side. So accordingly, I'm writing the code here. So as I said, we have 8 pins, 7, 6, 5, 4, 3, 2, 1 and PB0. And now let's consider that we have connected one LED at port B0. And what about other pins? Port B7, port B6, port B5, port B4, port B321 are not connected with any peripheral. We are just connecting one LED with port B0. So now we need to write the DDR, data directional register, for this port. How to write it? DDR B equals to 0B. 0B here indicates that now we are going to write the logic in binary. Here we are going to write the logic in binary. And then as we have connected the LED at pin number 0, port B0, we need to declare that pin as output. Why output? Because suppose if we connect the LED at any of the pin, for example, I am connecting a LED animated with port B0. So that means if we want to keep this LED on, we have to give the logic 1 from port B0. And if we want to keep this LED off, we have to give the logic 0 from port B0. So the direction of current is outward from the microcontroller. And whenever the direction of current is outward from the microcontroller, that means we have to define that pin as output. We have to define that pin as output. So according to this, for output, we need to write logic 1. All other pins are not connected. I am writing 0 for all of them. So 0 for 7, 0 for 6, 0 for 5, 0 for 4, 0 for 3, 0 for 2, 0 for 1, and 1 for 0. Right? So these port B7, port B6, 5, 3, 2, 5, 4, 3, 2, 1 are not connected with any component, and this is connected with LED. So writing this pin as output. Now let's take another example. Now suppose again you have port B7 to port B0, but this time all the pins are connected with LED. So if we want to keep all the LEDs on, obviously we have to give the logic 1. If we want to keep all the LEDs off, we have to give the logic 0. That means again the direction of current is outward from your microcontroller. Accordingly, if we see, we have to write the logic what? DDR. DDR B equals to 0B. 1 1 1 1 1 1 1 1. Why all 1? Because all pins we are using as output. Now let's take another example. Again, we have port B7 to port B0. It's not mandatory to take port B always. We can use A, C, D as well. But currently, I'm taking example of port B, so I have to write the logic of port B also only. Now this time I'm saying all these pins are not connected, but port B0 is connected with a button, or port B0 is connected with a sensor. Right? Now suppose I have this and I'm connecting a button with it. Button. So this time what we want, like whenever we turn on the button, we want the controller to do something for us. And whenever we turn off the button, we again want the controller to do something for us. That means this time, this button is giving the logic to controller and controller is receiving the logic. That means the direction of current is inward to microcontroller. And if it is inward, that means we are using that pin as input. So this time we have to write the logic for input. And for input, we have to define using 0. So let's write port DDR B equals to 0 B 0 0 0 0 0 0 0 0. Now the point is we have only connected one pin as sensor or button. All other pins are not connected, but still the code is same for all, that is 0. And why there is so? Because in binary we have only two logics, the 0 and the 1. The 0 and the 1. So here we are defining 0 for input as well as 0 for not connected, because we do not have any third logic for not connected. So if we don't have any logic for not connected, what we can do, we can define all pins as 0. And in some cases, like if we see this code, we might get confused that these 7 pins are as input and the last pin as output, because 0 indicates the input and 1 indicates the output. So right now we know that we have only one LED connected with it. That is why we declared this as 1 and other pins are not connected. So we make it 0. But suppose if you are reading the same code after 10 days or 20 days or let's say 6 months, according to your concept, according to your logic, you know that 0 is defined for input. So what we will understand by this code, that all these pins 0 are input and this pin is 1. That means output.
Sir, I have a question.
Yes, please.
Sir, here you are using a switch for input, but in this case, we want a 5-volt input for uh, one input, one uh, in a switch.
Correct?
Yes, sir.
Okay, actually, I am just telling you about DDR, not I'm telling you about how to make the complete connections that we will do later once we start the first program. First, we are trying to understand the basic concepts when we start programming. Okay, so in this code, what we will understand after 10, 20 days or 30 days or after 6 months that these 7 pins are input and this 1 pin is output. But actually, there is only one pin which we use for output and all other pins are not connected. So what we can do in those confusing cases, we can define the whole port as output. Let's clear the confusion and let's declare whole port as output. And it's not going to affect the programming because we have just defined the pins as output. We have not given any logic to that. If if suppose we have to give the logic, if suppose we want to turn on the LED or if suppose we want to turn off the LED, we have to use another register, that is port X register. So for port X, I'm writing here port B equals to 0B. As I know, I have only one LED which is connected with port B0. All other pins are not connected and we don't want to give any logics to those pins. So simply write 0, 0, 0, 0, 0, 0. 0, 0, 0, 1. Last is 1 because we have to turn on this LED. And if we have to keep this LED off, next code is port B0 equals to 0B, 0, 0, 0, 0, 0, 0, 0, 0. To keep the LED off, I write 0 here. In the same way, if suppose here we have to turn on all the LEDs, what we can write 0B, 0, 0, sorry, no, not 0, 0, turn on. That means 1, 1, 1, 1, 1, 1, 1, 1. Now suppose if we want to turn on only these 4 LEDs and we don't want these 4 LEDs. So how to write the code? Port B equals to 0B, 0, 0, 0, 0. These 4 LEDs are off, 1, 1, 1, 1. These 4 LEDs are on. In this way, we can start writing the port output registers. Now, if we talk about this one, here we cannot use the port output register because here it's a button, here it's a sensor, here it's a switch, which we are using for input device. And if we are using any pin as input, we are not allowed to write any logic to that. Because here button will give the logic to controller, not the controller will give the logic to button. So we don't have to use the port register if we are using any pin as input. That's it.
Okay, okay, that's why we are using write 0, 0.
Yep. Done. Now, next, we understood about the port registers, DDR registers, header files, then predefined functions, then loops, operators. Now we have data types: int, char, string, long, and float. This data type we use to define the variable in integer form, in character form, in string form, in long format. Long format is like if you have a number which has 10 digits or 15 digits, you can consider that as long format. And float, where you have decimal values like pi, 3.14. And what is character? Character like A or B or C. But what is string? String is a set of characters that mean ABC. Like my name is Ashok, so Ashok is a kind of string. But if I say character, then A, S, H, O, K. These are characters individually. We cannot say that Ashok is a character because Ashok is a string, not a character. Now next, we have while loop here. While one.
Sir,
Yes.
double data type are missing.
Double are integers only.
Okay, okay.
Yeah. So now we have while one. So while one basically we use to run your code repeatedly, to run your code in a loop, to run your code in a loop. That means suppose if you want one LED to turn on and turn off, that means if you want the LED to blink infinity period of time, you can use while loop. And if you don't want your LED to blink infinity period of time, you can use while zero loop. So there are two loops, while one and while zero. Then one main important loop is called int main. Start your curly braces and your curly braces and write your main code here. Whatever is your main code, you have to write that code here. Double slash we use to comment. So double slash we use to comment. To terminate the line, we use semicolon. Now we understood each and everything about this. So let's create the first program. So what I'm doing, let's create a connection. I'm trying with port C0. Any questions? Okay. So now we have two pins in this LED, the positive pin and the negative pin. I'm connecting this with port C0 and connecting the negative pin with ground. Why I'm doing this ground? Suppose if we have to turn on this LED, we will give the logic 1 from here. And if we have to turn off this LED, we will give logic 0. And here we have constant 0. That means here it is 1, here it is 0, here it is 5 volt, here it is 0 volt. So the potential difference is 5 volt and LED will glow. Here we have 0 volt, here we have 0 volt. There is no potential difference, so LED is not going to work. So that's why I'm keeping this constant as ground. That this much only we will be doing in a simulation. Now let's create the program. So here we have a software called Atmel Studio, which I already shared with you guys. This is 6th version, Atmel Studio 6. I just opened this and now how to create the project. Let's see. Let's click on new project. And we are going to use C language, not C++ language. And the compiler here is called GCC. GCC is your compiler. So we have to select GCC executable project. GCC C executable project. So I selected this one. Now you have to name the application. Like by default, it's saving this with the name GCC application 1. If you want to change, you can change it to first, second, third, your choice. Any name you can mention here. But you cannot start your name with any numerical number. Or special characters are also not allowed here. Then it's asking for the location where you want to save your project. So by default, the location is there, but I'm changing it to your batch number. And how I'll do that? Simply you need to browse, go to desktop, create a folder wherever you want to save. It's not mandatory to store in desktop only. You can save in any other drive as well. So I'm selecting this batch 10 p.m. 21st June. Select the folder and then let's click OK. So your file is created. You just now need to select which controller you are going to work. For example, if we are going to use with 16 at mega 16 for now, let's select at mega 16 and click OK. So finally, it will show you the programming window where you can start writing the code. This one is your programming window. You can see the name of your project is first and the name of your program file is first.c. That means you are writing your program in C language. Then here it will show you the list of errors. Here it will show you all the library files, dependency files, output files of your project. And if you want to see the properties of Atmega 16, you can see here in the property section. Now, as I said, we have to include the header file hash include avr/input output.h. We can see the header file is already there. Then int main we use to write the main program, and while one we use to run the process repeatedly. Let's see what we are going to do now. Let's create a small program to turn on this LED. Let's create a small program to simply turn on this LED. So what we have to write at first, DDR-C, as we are using port C and port C0 we have to define as output. All other pins are not connected, but still I said, let's not create any confusion. If you are using any port as output, any ports pin as output, and all other pins are not connected, you can define the whole port as output. So that's what I'm doing here. We can write it in two ways, 0B, 00, 00, 00, 01. That means this pin as output and not, or on all other pins are not connected. Or otherwise, we can write it in this way, 11, 11, 11, 11. Let's put semicolon here to terminate the line. Then after this, we have to keep this LED on. So let's write port C equals to 0B, 00, 00, 00, 01. So we are done with the coding part. We give the logic 1 to port C0 and the LED is also connected with port C0. So it will turn on your LED. Now let's build the project. Let's build the project. Why to build the project? We are writing this code in C language, and the machine is not going to understand your programming language. Machine mean your controller. Machine understand only low level language, which is called machine language, which is also called binary language. Machine only understand the zeros and ones, and we are writing the code in text format, in C format. It's very difficult for us to write the whole code in 0 and 1s format. If I'll ask you to write hash include avr/input output.h in binary format, it will be very difficult for us. So we have a compiler. Compiler is pre-installed. Whenever you install this Atmel Studio, it will install the compiler by itself. Now, what is the role of compiler here? Compiler will convert the human understandable code into the machine understandable code. Also, it will try to find out the errors, the syntax errors in your code. For now, let's build it. Build first. So I'm building, and it's building the code down there, and I can see the result, that is 1 succeeded or up to date, 0 failed, 0 skipped. That means the code is builded. Now let's see. Let's say if I'm removing this colon, semicolon, and I'm building it now again, build first. So this time it will show you a error, expected semicolon before while. So here it's showing you error. If you double click on the error, it will mark the point of your error. So it's saying put semicolon before while. So I did that. Again, I'm building it. And now I can see the project is built successfully. There is no error. So let's run this code in this microcontroller. Now how to run? Just double click on the controller. Here we have program file option. Yellow color icon is for browse. So let's browse it. And then let's go to the location where we saved the project. Batch 10 p.m. 21st June. The project is here with name first. Let's open it. Here we can see the debug folder is there, which it created by itself. We didn't create this folder. So let's open this. And here we can see the file first.hex. We were writing the code in C language, but compiler converted that language into the machine understandable language, that is .hex. Hex means hexadecimal here. So let's select the code. Let's click OK. Let's play. And now we can see the LED is turned on and my program is working absolutely fine. Do you guys have any questions or doubts in this?
No, sir.
Okay. Okay, fine. Now, if I tell you that what is the need of this program, what is the need of this Atmega 16, we can turn on the LED without that as well if we connect the battery source with it. But actually, for this program, there is no need. But what we are going to do after this, we need the programming part. Because if we connect the battery source, we can only turn on the LED. And suppose if we want to keep it off after a second or after 2 seconds, we cannot do that using the battery source. That time we need to write the program. So let's do the same thing. I am saying turn on the LED and after 1 second, turn off the LED. So for 1 second delay, we have to write delay function underscore delay underscore ms and 1000. And after this, I am saying port C equals to 0B 00000000. That's it. Let's build the code. What we said, turn on the LED and hold for a second and then turn off the LED. So to turn off the LED, we are writing 00. To turn off the LED, we are writing 00. Now it's saying build failed. 0 succeeded. That means build was not successfully completed because there was an error in this code. And what is the error? Let's see the error list. Implicit declaration of function delay ms, undefined reference to underscore delay underscore ms. Your compiler is not understanding this function underscore delay underscore ms, and reason being because we have not declared the header file for delay function. As I told you, wherever you use delay function, you have to write the header file for delay. So let's write the header file hash include util slash delay dot h. And now let's build it. So this time we will get the message build succeeded, 1 succeeded, or up to date, 0 failed. Now let's go to compile controller. Let's stop your circuit. Let's double click again. Let's browse. Actually, we not need to double click again. We not need to browse again because we edited the same file first and it was already having the address of that file. So you not need to double click. You not need to browse. Simply stop your circuit and play again. And play again. So now I can see the LED is on and after a second is off. It's off. Again, I'm playing it. Again, I can see the LED is on and after a second, the LED is off. Correct? Guys, do you have any
Sir,
questions
I
or
have a
doubts?
question.
Yes, please.
Yes, sir. Sir, every microcontroller needs some frequency, but in this case, we are not using any crystal oscillator in this microcontroller. But this microcontroller working.
See,
Why, sir?
one sec. The class is about to over, right? We will discuss about it tomorrow, or otherwise, I will guide you to check the last video of yesterday because that time I told you this microcontroller already has the oscillation frequency of 1 megahertz. And if you want to increase, that time we can use external crystal oscillators, which we can connect with pin number 12 and 13, XTAL2 and XTAL1, which will increase the frequency up to 16 megahertz.